Hello and welcome to another video for IGCSE Math. Today the topic is optimal expression or equation format for a desired trait. We're going to be seeing a lot of algebra here, and we'll see how equations have to be kept in order to find a desired result. Okay. Um, the first question says a manufacturer wants to produce a rectangular box with a volume of 500 cubic inches. The length of the box should be twice the height, and the width should be three times the height. Okay, the length should be twice the height, and the width should be three times the height. What is the expression for the length, width, and height of the box? Okay, so the length should be 2h, width should be 3h. Okay, and if I were to work with the volume, it's length into width into height for a rectangular box. That's 500. And okay, then the length is 2h, width is 3h, and height is h. So 500 divided by 6 equals to h cube. And then I need to take a cube root. A cube root is power 1 over 3. So let's see if that is the answer option. Yes, I have one that looks like this. So I'm going to say that that's the correct answer option. Okay, the expression for the area of a rectangle is given by area equals to length into width. That is what we all know, where L represents the length and W represents the width. If a rectangle has a desired area of 48 square inches and its length is twice the width, what would be the value of the width of the rectangle? Okay, so 48 2W into W, that gives me 24 equals to W squared, square root of 24. Is that the correct answer? Let's check. Okay. Question number 3 looks very similar to the one that we just did. It says a manufacturer wants to produce a rectangular box with a volume of 1500. The length should be twice the height and the width should be three times the height. So it looks like a very similar question. I can almost guess that the answer should be this. Question number 4. It says a rectangular garden is to be fenced along the sides using a fixed length of fencing material. The fourth side of the garden is against a wall and does not require fencing. If the length of the garden is L and the width is W, what is the optimal expression for the total length of fencing? Okay, so which is considered as width of the garden. The width is called L for some reason, okay? And then I don't know why this L here is bothering me. If the width should be called W. Width W of the garden and does not require fencing. They require two L's and one W. That is what my answer should look like, but I don't know for sure. Yep, there is some confusion about what width is, and the width is W meters, and then it says as width L of the garden. So there's a bit of confusion. This should be L, and this should be W. Okay, the formula representation to obtain the volume of a rectangular box is this, where L is this. If the box has a volume of 240 and a width of 6 meters, okay. What is the optimal expression for the length and the height of the box? Okay, so volume is equals to length into width into height. So 240 L into 6 into H. So that gives me LH equals to 40. So if I want to find L, it's going to be 40 over H. And if I want to find H, it's going to be 40 over L. Okay, so 40 over h and h, that should be the correct answer. Let's move on, find more easy questions to do. This is again a set of easy questions. A bakery charges a base price of $5 for a cake. Question number one says a bakery charges a base price of $5 for a cake, plus an additional $1 for a candle. If the total cost of a cake with candles is $15, so I don't know, let's call that N, is $15. So 5 plus 1N, so that obviously makes it 10. I don't think I need to do a lot of calculations there. The company produces and sells. Question number two says the company produces and sells with a fixed cost of 5,000 plus a variable cost of 8 per unit. If the company sells 1,000 units of the product, what will be the total cost? That's 13,000. Question number three, a store offers a discount of 20% on all items during a sale. If a shirt originally cost 25, what will be the final price? So if it reduces by 20%, then the leftover price is 80%. So what is 80% of 25? I'm going to calculate that on my calculator. I'm going to say 80 over 100 into 25. So that's 20. So that should be my final price. Question number four, a ball is thrown for the equation for the height of the ball thrown into the air is given by ht, where ht is the height of the ball at t seconds, v is the initial velocity in feet per second, and h0 is the initial height in feet over the ball. What is the optimal expression for ht to find the height at any time t during its flight if a ball is thrown vertically upwards with an initial velocity of 64? Okay, so 60/40 within from a height of 32. So that's plus 32 there. Okay, where h naught is the initial height. A rectangular garden fence. Again, this is the same question that we did before. So I think that was the correct answer. This one has the correct letters. Okay. I think W of the garden. So this one has the correct letters. It should have said length in the other question, but it didn't. So this one is correct because this time the variables are different. The wall is against the width. So I have 12 plus W. I think it's going to run through the questions one more time because I messed up one of the questions. The temperature in a room is given by the equation this, where T is the temperature in Celsius if a person is standing at a height of 2 meters. What is the optimal temperature? I think that's 24. A rectangular garden, this time it says width L, so it's going to be L plus 2W. That's an old question. I think we've done this one before as well. So I'm just going to push through the questions quickly and get you to the end of the session. Okay, that should be it. I think that's going to allow me to level up now. So I'm going to be back with medium questions in the next session. Thank you for watching.